it is probably better to use AI as a teacher or as a student if you are supervised by some teaching assistant or teacher who is knowledgeable, because my experience is that AI provides a lot of answers which are seemingly correct, but when you probe it, it's only superficially correct in many cases. In some cases, it's correct, and on indicating to it why it is wrong, it seems to produce revised answers which are sometimes correct and sometimes not. So it is more useful for an experienced user of the subject, for example, even to prepare their own exams, notes, and other things. And to a lesser degree, students will benefit from it. They will benefit from it if they use it in conjunction with independent thinking as well as assistance from people who are more knowledgeable. This is not really something very new in my opinion, because a similar scenario or predicament was experienced around 2000 or 2005 or so, when the internet exploded and we had newly had access to search engines like Google and so on. So basically, what you do, you search for something, you get something. But the onus is still on the teacher or the student to figure out that what you have got by your search and results, by way of search results, is correct or not, because essentially what is put out by search results is a collection of what has been put up by users. So some users or content creators put up accurate information, and others may put up somewhat less accurate information. Others may put up complete bunkum there. So one has to be able to differentiate what one is being supplied when we use such tools. So it is a useful tool if one uses it with discrimination. I have chosen to speak about its role in algorithms and problem solving and data structures, which is a kind of important subject in computer science, because I have some experience in that, whereas let's say I have some limited experience in using AI, and I do not want to give a generic talk on things which I do not have practical experience with. And I am aware, as Mahipana said, the audience is quite diverse. So whatever I am saying with reference to algorithms, data structures, and problem solving might be better adapted by each expert or each teacher who is going to utilize this in a manner suitable to their own subject or courses which they teach, or any other academic activity like even research also. So with this, I will also give a brief overview of the course about which I'm going to speak about the role of AI, because we have been told that the background of the audience is diverse. Not everyone is from computer science background. So prior to getting into that, I just give an overview of I haven't really shared my slide. Did I say? Sorry. So I'll begin with a brief PowerPoint presentation, which indicates what I'm planning to cover. And so here, demonstration focus AI in teaching data structures and algorithms, programming, let's say problem solving. So the main focus of what I will be covering is concrete examples of say small problem statements, not very advanced, which might arise in a course on data structures and algorithms, either in the form of the material covered or tutorial questions or exam questions and so on. And I will use ChatGPT to use the prompt to pose questions, and we will get some responses from the AI, and we will see where the responses are satisfactory and where they fall short. And where they fall short, we will try to communicate to the AI program that this falls short for the following reason, and see if it gives something better, and see how it revises itself. In some cases, it will revise itself to our satisfaction, and in other cases, it may fall short. And this is the alarm bell as far as students are concerned, because a student who is not very experienced may not be aware of correct and wrong answers in a particular subject. And the real problem with the wrong answers in ChatGPT is The answers are wrong, but the confidence is unnerving. The coherent writing, clarity of apparent clarity of thoughts and flow and so on is alarming. Giving a completely wrong answer, it can sound totally confident. You cannot see anything wrong with it if you do not know the subject. So this also suggests that students must use it in a supervised fashion. Instructors can use it because it allows one to quickly generate content, maybe exam questions and so on. It may, in several instances, give something which is reasonably good, which is not ideal. But since the teacher is usually experienced and aware of the subject, it can serve as a starting point to accelerate the process. So you have a lot of content ready, and after which you can basically edit it and do certain things. Maybe you can give one sample paper and ask it to generate a different one of similar difficulty level and so on, and it does these things really well. For example, I made a very small set of slides, just 3 or 4 slides, because I just wanted to present the outline, and largely I wanted to demonstrate the action, I mean, ChatGPT in action, which is a chosen platform for today, on questions of data structures and algorithms, and how it performs, and therefore what all we should be aware of when we use it. So the main point being, usually I would have spent around 3 hours maybe, because I'm rather slow in preparing these 4 slides. And yesterday, as I was preparing with ChatGPT, I decided, let me see how it does it. And these slides were prepared in under 5 minutes. And after that, I tweaked it a little bit. Of course, I'm not sure of the quality, but it seems better than the slides I used to make in 3 or 4 hours. So in a lot of ways, it's a compelling tool if used correctly. So structured prompt can make abstract algorithmic concept more intuitive and engaging for learners. We'll see how it goes. The approach will be to ask several questions. My approach, what I'm reading out here is basically my plan for the current lecture. Ask several interesting questions from data structures and algorithms course. These questions will be given to the AI prompt to analyze its responses. We will identify both the good aspects and the flaws in the AI generated reasoning, which we are going to get when we run it. Demonstrate how feedback can guide the AI towards better responses by indicating what went wrong. We'll tell the AI why we believe this is not correct from our knowledge, and we will try to take our feedback and regenerate something. If it still does not generate something adequate, well, that's an indicator to us that it is just a tool. It does not, at least for the moment, supplant or replace human beings' role in this. It should also, in my opinion, be shared with students during lectures, not the entire course, but during a few lectures, maybe or a tutorial session. Show the students what you are asking, what the AI is giving in response, what is wrong with the response of the AI and why, and how it, when we give it back to the AI, it then again gives a improved response, hopefully, sometimes still not adequate. The importance of emphasizing this to the students is, I mean, it's very high. The reason is a lot of students are under the illusion that ChatGPT or any Gemini or something has given me this, so it must be correct. And this is something which is very important to dispel. It's a myth which has to be dispelled from the student's mind. And this can be done by showing them how many times it goes wrong. And therefore, it is something like a tool which needs to be used because it gives some quick responses. And once it gives something, one should critically analyze it on our own. It's not like students cannot analyze it because they do not know the subject, but they do not know it that well, they are not that experienced. So they have to look at it, think carefully on their own. And if that is not adequate, they can take assistance of the teaching assistants or the instructors to get a better idea. So AI provides skeletal or coarse responses that does not that may guide but not replace understanding. As I attended a recent talk, one of the persons said, you may prepare your slides using artificial intelligence and think everything is there and that you are ready. But if you go unprepared for your lecture with such slides, and even 1.5 students, exact words of the person who gave this talk, even 1.5 students in your class knows what is going on, you are in serious trouble as an instructor if you are not aware of what is going on. So it's extremely important that one does not believe that this is going to basically run on autopilot. It is going to be a guide. One analogy, maybe a very well-known analogy, could be a maze. Basically, a maze is a network which gives you roads, and you have to figure out your path to the exit, as you are aware of. So the mere fact that there's a maze does not mean that you know where to go. Solving the maze is still something which requires skill. So ChatGPT's output could be thought of as a maze or some road network or something. You need to still figure out your way around it. Uh, so is that, well, again, just a summary. But it would have a summary here before I get down to actually the interactive part. AI's role in education is to assist, not replace human reasoning. Learners must remain analytical, skeptical, because skeptical meaning suspicious. Don't take everything the AI says at face value, because the AI does make a lot of mistakes. And reflective when engaging with AI generated content. Reflective means you have to think about what it is saying. Uh, it's useful because it's giving you some material quickly, but you still need to evaluate what is correct and what is wrong. Educators can leverage AI to create dynamic and interactive learning experiences. Because you could, for example, supply quick responses on the fly to demonstrate to students who are learning on what goes on. True learning lies in critical engagement. AI provides a framework, but understanding must be built by the learner. That is evident. And again, I just go back. Nothing has changed. In the 1980s, there were textbooks. Same thing. Textbooks, teachers, you still need to do something for you to learn. 2000 or so, there was internet. There was a lot of content, and there was search engines which basically give you links to websites with relevant content. The search algorithm have improved. Again, you still need to figure out what is correct, what is wrong. The same thing today. AI is basically farming a lot of available data, but it is doing a lot more than simply supplying links. It is kind of processing this data, making capsules, and giving it to you. It still goes wrong, just like a lot of other things, all the other methods did. So it does not take away the need to engage when you are a learner or a user or anything. Okay, so this is the end of my presentation here, and I plan to get on with showing ChatGPT in action. But maybe prior to that, I will also kind of give a quick outline of the course of data structures and problem solving. So before I proceed, is there any feedback? Okay, fine. So I just proceed. So the course I'm trying to.
Yes, sir, it's going fine.
Yeah, okay. I'm just going to. I'm not going to chat GPT yet, because I just want to give an outline of.
Yes, you can
the courses
just
I'll be.
outline of the course first, and then we can go ahead with interactions which you are going to showcase.
Okay, so I'll go ahead with the lecture completely, and yeah. So the focus will be on. Is the font visible, beginner? So I am going to focus on this: algorithms, data structures, programming, and problem solving. Basically, this will be the key focus of the role of AI in education. It will be on a relevant matter to this course. So, as we know, we model a lot of practical problems in terms of some standard uh, methods and write computer code to solve them. Although the variety of problems that arise is quite diverse, a lot of standard data structures, programming constructs, and algorithms they're like standard tools which can be put together or tweaked, and in many cases modified, but still the basis of problem solving lies in these kind of well-known structures, programming methods, data structures, and algorithms. So, what is a data structure? Data structure is a mechanism to represent data uh, used for computer programs, data or data manipulation systems used for computer programs, which facilitate accurate, efficient, and convenient representation of the data, so that it can be used in a suitable way to efficiently solve computer problems using computer programming. Data structures represent the mechanism by which data is stored in memory and processed and so on. but it is a little more abstract. We do not actually deal with the aspect of how it's stored on physical computer memory. It is more like the mathematical layout in some sense. Of course, there is a real physical equivalent, but all the concepts are at a mathematical level and are a reasonably accurate reflection of how data is actually stored on the computer and why the way the data is stored on the computer allows us to process certain kinds of process the data in certain kinds of ways that are appropriate for our task at hand. What are algorithms? Algorithms are a precise formulation of the mechanism to solve a particular problem. Like for example, sorting of numbers, finding paths in your graph, trying to disrupt a network, trying to prevent a network from getting disrupted. Well, both of these have applications. You want to prevent a network from getting disrupted if it is yours. You want to disrupt a network if it is an adversary who's harming you and the network is helping them harm you, then you want to disrupt the network. So a lot of kind of computational problems are useful. We may also talk about logistics, like setting up retail outlets, setting your commodity flow when you're trying to do supply chain management and so on. All of these well-known problems are solved using algorithms and standard computer program modules which are put together appropriately. Okay, so this is the focus. Programming is when it's actually implemented on the computer. Algorithms and data structures that are more abstract level. Problem solving is at an even more abstract level. We have real-world problems to be solved, or like for example scheduling or anything else. They are all modeled with the various mathematical models. So you have a real-world problem. Real world has a lot of variables, lot of uncertainties. Everything cannot be taken into account when actually attempting to solve something. So there are always unpredictable elements. So nothing is perfect in the real world. Computer programs have their limitations. So we have to draw a cut somewhere, make some approximations. So what happens is the real world problem arises. You build a mathematical model for it, which will take care of the most significant features. Every feature cannot be taken care of. You then solve the problem, deploy a solution in practice. Corner cases are always there, nothing can be done about that. Once you have modeled it, then it enters the domain of computer programs and so on. You use ideas of problem solving, which make solving problems efficient. Certain ideas which will make the solution meaningful and efficient and so on, and accurate. So this is the framework of this course and what is covered in this course. So some examples of data structures and algorithms. I'll just give a quick outline of the things that are taught in this kind of a course. So data structures usually precedes algorithms. So data structures, let's say you have contiguous memory data structures. Standard examples of this are arrays, two-dimensional arrays. Basically, then you have pointer-based data structures. Here, aggregate data concrete example are linked lists, pointer-based trees, among others. And some standard problems that arise in data structures algorithms are sorting, searching. We have hash tables and which is advanced data structure which solve certain problems. And when you have sorting, searching, works on the various things, balanced trees, imbalanced trees, and so on. This is as far as some simple data structures are concerned. Most basic data structures. For algorithms, the focus is more on the problem solving, generic problem solving methods. So of course, tables in general are also important. Adding to dimensionality. So algorithms, you have simple iterative algorithms, which basically go in loops and keep performing some tasks. And at the end of several rounds, the task is complete. Recursive algorithms. Here, basically, recursion, let me say, function calls. In programming, certain kind of programming called procedural programming, problem solving is divided into separate modules. Each module does independently a certain task. The modules are combined with each other by, for example, one module executing some task, then passing control to another module. That module executes some tasks, returns control, and so on. So there's a kind of a flow structure. Why do we do this? Because problems in general are very complicated. And if you attempt to solve everything in a single piece, it becomes hard to keep track of errors that creep in and so on. So it's important to separate these. Also, identical kind of units may be used in different problems. So you want to generate these functions and use them wherever they are appropriate. So function calls. Recursive algorithms are basically the function calling the same type of function as against a different type of function. So function calls, iterative algorithms, then you have divide and conquer. Here, on certain large problem which you are trying to solve is broken into smaller sub-problems which are similar in nature. The problems are similar, but the specific instance on which you are solving it are both smaller and different types. Use the solutions to the smaller sub-problems to get solutions to original problem. This is used in a lot of problems. Then you have greedy algorithms, typically used for optimization problems that are simple in nature. So since they are simple in nature, they are amenable to a very obvious idea. That's why they are called greedy, which typically fail on more complicated problems. The mechanism for addressing those more complicated problems is called dynamic programming. Here, basically, again, it's like recursion. A big problem is broken into smaller sub-problems and solved, but there are certain aspects. The same sub-problems arise a large number of times. So solving the same problems again and again is a lot of wasted resources. And also, when you're trying to solve an optimization problem in terms of smaller sub-problems, there is a certain attribute which says that optimal solutions to the smaller problems are enough. You do not need to consider suboptimal or dubious solutions. So all of this results in a collapse in the amount of computation done, bringing down the running time of the algorithm from an exponential function of the input size to a polynomial function of the input size, which is in common parlance something which is considered good because it can be implemented practically on a computer as against the former case which is like prohibitively expensive and does not run in reasonable time. So dynamic programming is there. And towards the end of the course of algorithms, you typically run into or you typically present what are called very hard problems that arise frequently. But are not known to have efficient solving. These are usually go by the name NP complete. And of course, there are even more difficult problems. So these are the kind of material that is typically covered. And of course, graph algorithms, because graphs and networks are very important. So these are the graphs and graph search algorithms. So searching in a list is only one thing, but searching as a term is a central. Searching is central as a tool in an algorithm's course. And here I don't mean the searching as search for an element in a list, but a more general meta notion of searching. Why do I say this? Because algorithms course typically solves computation problems, which means you are provided with some input and some idea of what you have in mind for an output. And the job of the algorithm is to find and return that output. So find and return an output from potentially large number of configurations which constitute the output is nothing but searching the potential solution space for an actual and correct solution. So searching typically means, in the most basic sense, searching might mean there's a list of some type of item and you search for a particular item in the list and return it. That's what you do in the beginning of the course. The arrays, search for some number or something. But searching is a very important central meta technique in algorithms course because it is the essential idea behind the solution obtained by any algorithm. There's a search space of potential answers. You throw away all the junk and zero in on the correct answer. In some sense. So this is as far as the course outline is concerned. And yeah, I would say that that's about the second stage of. Okay, I want to close it like this. Yeah, this concludes the second stage of my talk. So now I plan to move on to use of AI, which was the core focus, but I thought I'll use some time to present some background material. Is there anything anyone would like to ask or comment on right now before I move on? Okay, so then
Okay, sir, just a small request. After you cover how we can use ChatGPT for kind of validating and observing the responses and then refining them, one more unique kind of, one can say, domain or problem is how to generate good questions in AI era, right? And I have seen your question papers. So because nowadays we are going to allow very soon that for most of the students these systems will be available. So then the challenging question for all the faculty members will be how to come up with nice questions or creative questions, problem solving based, which cannot be solved directly with the use of LLM, and students must have to think by their own. Again, it's not very, I know that it's not a very easy thing to answer, but I feel that you can give us some insights. There is no specific, one can say, pathway to learn this, but I request you to include this towards the end of your topic.
Yes. No, I like this because it's almost like a what do you call this standard thing? It's like a two-player game. There are conflicting forces because on the one hand, at least the companies and people who are looking to push AI as a great tool are looking to empower it more and more such that it can solve everything correctly. On the other hand, we want the same thing not to be able to solve something correctly. It's something like I often see that they say they want you to confirm that you're a human being by identifying all cells which has a picture of a bus or a cycle or something to verify that you're a human being. Or so when you try to crack it. So that is on the one hand they are saying you have to be a human being to do this. On the other hand, the same corporation is saying you submit a random photo and say it looks like there's somebody in the beach with the sun rising and something going. So this looks to me in some sense to be highly conflicting forces at play, but when that happens, and remember there is
what I feel is it's more about where we are at our in some sense at career stage. For the students especially, they haven't developed their creative thinking and problem solving abilities to the fullest. So for them, we would like to kind of design question paper so that it can be facilitated that their independent thinking.
That is one good thing.
But
That I
for these researchers like you, right, you can utilize it to with the help of AI, you can get some X level of let's say
new ideas, right?
and then we can of course we can use it for enhancement, not
Yeah, even new
replacement.
ideas maybe, because you know many things, but you may get some quick insight because it says something and somehow triggers a thought. That is right. On the other hand, once how to generate
Briefly
creative.
about this towards the end of your session, if you can give some
Sure.
ideas.
That's one thing. But I think also, so in carrying forward what Mahipan has said, it is important to get creative questions so as to ensure that students do not directly rely on this. One other approach to students not rely on this is to show them how badly it fails by using it in one or two lectures and saying that is what I want to show today. So I hope the combination of the two, one is reward, one is that the questions themselves may be hard, and even if they are not, if you put in some diffidence in students by showing them several examples of where AI goes wrong, then they will lack that confidence. So I am confident that students get, I don't know where they get it from as of today, because you can see a lot of examples where the AI generates wrong answers. So it could be a twin approach. One is what Mahipal suggested, other is which I observed yesterday, that the AI gives wrong answers. So if you can convince your students that they are not really entirely in command if they surrender their brain, that also will go towards achieving the similar target. It can be a combination of it.
And also, sir, it's also about like whatever LLM we are going to use. They are mainly trained on the data which is available on web. So if something is available on web, then similar type of questions we are going to ask, then of course it's going to give correct answer. But if questions are something out of the box kind, then AI will struggle. So that's
Yes, absolutely. I mean, something which it has not seen in its data space or where it has not seen good solutions. That's all. Yeah. But that. So, well, I think you have actually elaborated most of it on your own. So, which is good. I will just repeat that maybe. And how to generate good questions?
So maybe you can just give some questions which you had generated for your, or not generated, I should say, created for your question paper, so that it's.
We'll come to that. Anyway, yesterday I had tried certain ideas. So, so I asked. See, some things are asking questions. Other things are why do we care? Okay. Sorry. Pseudo polynomial algorithms often NPR problems involving numbers. So I asked the question. I think this is a repeat of my prompt. Somebody.
Your screen is not visible, sir. If you
Oh,
can.
yeah, I share. Yeah, I'm sorry. I forgot to share. So yeah. So this is yeah. So I guess it's visible now.
Yes, sir. It's visible.
So actually, this is not a fresh prompt. I already made some prompts, and Maipal indicated to me that since he's an experienced user, that a lot of the history is stored. So basically, I asked him, well, yeah, this is the question: what is pseudo polynomial time? So certain things ChatGPT is extremely useful. Let's say a student saying, what is pseudo polynomial time? Pseudo polynomial time is runtime classification used mainly in algorithms for number problems like knapsack, subset sum, scheduling, and so on. The idea being the answer is polynomial in the actual value and not the value as represented on the computer memory. Here is a very important contribution. Well, as they say, it's an ancient Indian contribution. Some other places had it. The contribution of zero, binary, decimal, octal, hexadecimal, whatever. Basically, any non-unary number systems compress the data exponentially, and therefore it's logarithmic in the size of the actual value. And conversely, the actual value is exponential in the computer representation. So there are certain problems where the runtime is not based on how it is stored on the memory being polynomial, there is exponential, but it's polynomial in the actual value. And these are called pseudo polynomial in some sense that are applicable for certain problems, prime number checking and so on. If you look at it, number n requires log n bits, but there was a breakthrough algorithm which actually runs in polynomial in the representation, but initially that was not the case. So here, this is an example of something which ChatGPT gives completely satisfactory answers to. Why do we care? Well, they have pseudo polynomial algorithms, strongly NP-hard problems do not. So there's a further classification. Weak NP-hard problems means if we give the representation in unary, it is polynomial type. But strongly NP-hard problems, even when you give the representation in unary, it is going to take not polynomial type algorithm. So in some sense, no pseudo polynomial type algorithm is known. traveling salesman is strongly anti-hard. So even in representation, being in unary, you do not have a good algorithm. So this is a classic case of ChatGPT giving a very good answer. Now I move to another question, which is central to, let's say, algorithms course. So there is this notion called self-reduction. And I actually did not correct ChatGPT. There is this concept called self-reduction, which allows someone to solve efficiently construction version of an optimization problem. For example, longest cycle in a graph, or let's say Hamiltonian cycle, which is a cycle covering all the vertices of the graph, using queries to a magician or a black box, often called an oracle, which can instantly return answers to questions which are of the type yes or no. It will not tell you, it will not give you a construction of a Hamiltonian cycle. It will simply answer the question: does this graph have a good, sorry, not good, does this graph have a Hamiltonian cycle? Yes or no? And you can actually use this to solve the construction version, that is actually construct edges of an Hamiltonian cycle. How does one do this? You basically ask whether the graph has a Hamiltonian cycle. If the oracle says no, then you immediately stop and say there is no Hamiltonian cycle. But if the oracle says yes, it is not going to help you answer any further questions. It will only answer the question: given any input graph, does it have a Hamiltonian cycle? Yes or no. So if it has answered yes for your original graph, you take some arbitrary edge and remove it. Give the same procedure, the reduced graph, which is a subgraph. Ask the same question on that subgraph. If the answer is yes, then there might have been an Hamiltonian cycle using the edge you remove, but there is also one without it. So that edge is not indispensable. You can do without it and still solve the problem. So you throw away that edge. What have you got? You have got what I call reduction or recursion, as I said, a smallest subproblem. On the other hand, if it says there is no Hamiltonian cycle once that edge has been removed, but the original graph had a Hamiltonian cycle, it indicates that that particular edge is indispensable or unavoidable. So you freeze that edge and say you cannot remove it. Proceed to remove some other edge. So at every query, either you are freezing an edge or you are throwing away an edge, with the guarantee that at the beginning you are told that there is a Hamiltonian cycle. So as long as there is at least one edge, every edge of one Hamiltonian cycle, every other edge is dispensable. So you will keep on throwing away edges and eventually you will be left with a Hamiltonian cycle consisting of n edges, which are the n edges of the graph. And this takes polynomially many queries to a magic box, which of course doesn't exist. But that's what the concept of self-reduction is. If I have a black box that answers the yes or no version, then I can answer the construction version by polynomially many queries. However, the same claim does not hold for graph coloring. So I asked, is graph coloring self-reducible? And it said yes. Graph coloring is self-reducible. What makes graph coloring not self-reducible was my query to the ChatGPT software. Graph coloring is self-reducible in the standardization search sense used in complexity theory. What you may have heard is that graph coloring is not known to be self-reducible, unlike many other problems. I don't know why it is number theoretic, but anyway. This is a different property. Below is a clear breakdown. Self-reducibility. Which kind? There are two different notions. Deterministic self-reducibility. Search to decision, self-reduction. So a problem is self-reducible if you can solve the search version using an oracle for the decision version. Search is what I mentioned, construction version, which is same as search version. Graph coloring is self-reducible. Given a decision oracle for does the graph have a coloring, you can find an actual coloring. For each vertex, we try assign color 1 and ask the decision oracle if the graph is still k colorable under that restriction. If yes, fix that color. If no, try color 2. Repeat for all vertices. What this algorithm is giving here, why is it wrong? It says the graph is still k colorable. It doesn't give you any further information because the graph is still k colorable. It's basically not going to give you something which is polynomial time reduction, because you color some second vertex and then you proceed. If it is wrong, you go. So this is more like a backtracking exponential time algorithm. What I was talking about was a polynomial time reduction. So it's like I assigned this color 1 and somehow I want the rest of the graph to be k minus 1 colorable or something. Unfortunately, that problem is not the same because it must have a free color in the neighborhood of the vertex, and this fails to address that question. The removed part of the graph, this is one vertex, plays a role in the rest of the problem. So one cannot directly solve it. So random self-reducibility is slightly different. The graph coloring is not known to be randomly self-reducible. So if it can reduce any instance to a random instance of same size, which such that it solves and gives a solution. This is very strong property. Anyway, this is not satisfactory to my mind. Essentially, it is not self-reducible the way I described for Hamiltonian cycle. You can't give. So what you can ask, for example, is take two non-adjacent vertices. The graph coloring problem requires an adjacent vertex get different colors. So for non-adjacent vertices, there is a flexibility. Either they get different color or they get same color. So you can suggest something like, if they get different colors, do something. If they get same colors, do something. If they get different colors, add an edge to force the conflict. If they get different colors, if they get same color, you can merge the two vertices and so on. So this does not give a satisfactory answer to this in this case. Now let me pose this other question I asked. Fixed point in BST. The query is, the original query was, the binary search tree, does inserting into a fresh empty binary search tree the contents of an existing binary search tree in post-order sequence repeatedly lead to a fixed point? That means you get the same tree again and again and again. Short answer, yes. Inserting the keys of a binary BST into a freshly empty BST in post-order always construct a tree isomorphic to the original BST, because the result is the same every time. This process reaches a fixed point after the first iteration. I contradicted this because a wrong remark, and I said this appears to be wrong because, okay, it's a detailed answer. Quick summary. Resulting in exactly the same shape as the original BST. This is wrong. Conclusion, inserting, whatever. Okay. This seems incorrect. This is my prompt. This seems incorrect because if a descendant is inserted before an ancestor, the tree will be altered. Okay. So it says it thought for 1 minute and 59 seconds. It says you are absolutely right. My earlier claim was wrong. So notice that if a student does not pay attention to what is going on here, it's very simple. If you know the definition of post-order traversal, you'll see that something has gone wrong. But if a student doesn't pay attention, post-order basically inserts the ancestor after the descendant. But the well-known algorithm for constructing binary search tree inserts from the root and newer nodes are inserted at the bottom. So if you insert a node different from the root first, you are definitely going to get a different tree. So here is a case where the AI basically gave a completely wrong answer. And then once I told it is wrong, it took this tree and then it said the order is 1, 3 and 2 and it inserted and got a different tree. Now if you look at it, the order is 2, 3, 1 and so it will get the same tree. So look at its next conclusion. So the iterating process doesn't get a fixed point, it enters a 2 cycle. So it gives the answer which I didn't challenge yesterday, I just stopped at this point. FT, etc. FT is the function which results in a transformation. Why this is true? So it basically says it will always give 2 levels. Okay. Now let us look at a complete binary tree. Complete binary tree is well balanced, and for example, it will give something like, let's say, okay, I'll come to that later. So it has, for example, 7 nodes, one at level 0. It has 2 children, and each of the 2 children have 4 children. The post-order traversal of this would basically place the entire left subtree's nodes first, followed by the right subtree's nodes, and then the root. As a consequence, the root will be inserted last, and the minimum element will be inserted first. But again, it will not be in order. For example, if I have, well, let me draw a concrete example with. Okay. So I'll just use a. I'm sharing the new window. Sorry. Okay. So here we have this. I'll use a text box to represent my nodes of a binary tree. So here, for example, I have A, I have B, C, D, E, F, and G. Okay, so sorry, it's not ideal, but I just draw some straight lines for some link. Let's say this is a straight line. So I have a link. So I have a link here. I have a link here. Okay. Now the post order traversal for this would be the following. You would have basically A last. Then here you would have basically D, E, B, F, G, C, and A. This is the order. Now if I want to insert into this in this order, you are going to get a tree which is basically D first at the root. So just use a Excel mode is easier. I'll let a D here, and then I get E which is D which is bigger. I have E which is bigger, so I have E here, and then I have B which is again bigger than this and bigger than E as well, smaller than E. So I get B here, bigger than D, smaller than E. So I get this structure which is currently given by ChatGPT for 3-node tree. And similarly, I get F. So F is bigger than all these three. So bigger, bigger, bigger. So you get F. And then you have G, which is bigger than F. So you get something like a G going here. And then you get C, which is bigger than all these but smaller than G. So it will be on the left side here. And then you have A, which is bigger than these three and smaller than C and so on. So it's smaller than F, C, and D. So it will be on the left hand side of this F. So you're getting some strange tree and it is not going to repeat. So I'm going to go back to the prompt and tell it that it is wrong. So I have told it that it appears to be wrong when you take a bigger tree. It's only correct when you take, say, one small tree. So does it lead to a fixed point? It doesn't lead to a fixed point. Does it even lead to cycles of length 2? It is very unlikely to be a cycle of length 2. And so on. So a lot of things are going wrong here. But there is only one type of tree for which, oh, maybe it's correct. Maybe it's correct because essentially it's giving. Why is it never going to be a fixed point? Can anyone answer that quickly? You don't even need so much of. Yeah, like I don't know why I do this much. Okay, it doesn't give the correct answer. The reason is that you're inserting the descendants. Something is lower down the tree before you insert the ancestor. So it gives 7 node tree. First build this, then distinct keys. So it says it does not necessarily include the original 2. It goes T1, T2 something, and then F square of T enters the 2 cycle. So you don't get 2 cycle that includes the original balance tree. Instead, after the first application, the sequence enters a 2 cycle between Ft and F square of T. So now it has given a kind of satisfactory answer, because when you have a linear tree. So okay. So to summarize this, I'm not going to go into this in further detail. To summarize this, I have given query to the AI, which gave one wrong answer. Then I told it why it is wrong. It gave another answer. I told why that is wrong, and now it seems to have come up with the correct solution. Basically, to reach a linear tree, and after that, it's going to go back and forth between 2 trees, but there'll be no fixed point. So here is an example of how it has refined itself and given a correct answer. So if a student is unaware of what is going on, they will not be able to do it. So I asked if the 3 traversals the reality for a binary substring periodic processor produce different traversal, different sequences, except in trivial case. However, one of them order is special. Okay, this always produces the keys are ordered, but so it answered a different query. It talked about so I'm saying not the key sequence but the traversal pattern. So this is another classic example where ChatGPT easily fails. They visit the nodes, same node but in a different structural order. The traversal path is different. This is a wrong claim, by the way. Classic example of a wrong claim. Because what happens in all the 3 traversals, they are all resembling DFS, is that a parent calls the child node. The child node then, in one case, prints a key, then makes a call to the left child, then calls the right child, and then returns. Another case, it calls the left child, prints the key, calls the right child, then returns. Third case, it calls the left child, calls the right child, prints the key, and returns. But the order of transfer of control between the different nodes of the tree is identical in all the 3 cases. So ChatGPT is not able to see through this even after a repeat prompt. So this is why it becomes important. So I think I'm kind of done with time. But I wanted to show some, a few examples is all I could manage in this time to show how ChatGPT gets certain things correct, but gets a lot of other things wrong. Because the travel pattern is actually the same, and it's not able to see it at all. I guess I'll have to do a lot more queries. And so a student would, if given this question, would argue that ChatGPT said the travel patterns are different. Hence, that is the correct answer, and in fact, it's the wrong answer. Basically, how I like to describe this is you come to office and you have two activities and a coffee break. So you can either have your coffee break first and then do all your activity, which is like pre-order, or you could have an interval, which is called in order, or you could do all your work, relax with the coffee and leave for home, that is post-order. So in some sense, the order in which the transfer of control between nodes happens is not at all different, and this is something which I've observed not a standard question. This is a non-standard question which many people get wrong while trying to answer. Okay, sir. So I think I'm done with the basic part. If any question answers or anything else, some questions I could think of. So I have demonstrated how ChatGPT basically gives certain standard theoretical questions good answers. Certain others it's able to calculate with some time. But as you saw, it was able to calculate a binary tree question and give some answer in time. So maybe if you give more time, it will be able to answer. It requires skillful use by students or instructors. It cannot be taken blindly. So, is there any? What will be the next part? Is
option of share over there.
sorry. No, I'm not able to hear. Sorry.
If possible, just share it so that we can go through this conversation one more time whenever we would like.
No, your voice is breaking apparently. Or is it only my system? Is it possible for you to type in that common chat maybe? Or I could hear Mahipal earlier. So yeah, you're audible now. But it was breaking. Who is speaking? Is it Mahipal or somebody else is speaking? Because audibility is intermittent.
Okay.
Hello?
Means that if possible, share a couple of conversations with.
Share a couple of.
Am I audible?
Yes, you're audible. Okay. Share a couple of.
Yes, sir. Am I audible?
Yes, you're audible. You're audible. But
Just give me a minute. I guess there are some issues with my.
Can you?
Okay.
What is the? Who is speaking?
Yeah. What I was recommending, a couple of.
I can only hear it. Couple of.
So if you can just share those links with us so that we can go through this entire conversation afterwards also. Right? Because very nice presentation. Thank you, sir, and also. What are the good prompting frameworks and it's also equally important to analyze, interpret the results which are given by this. I hope I am audible. चेक करो तो ये नहीं जा रहा वॉइस तो इतना कनेक्टिंग आ रहा है
Audibility is quite intermittent on my end. I don't know. Earlier I could hear my part clearly. Is it somebody else, somewhere else? Because the audibility is not clear. Mic or
Okay, I hope I'm audible now, sir.
sorry, what is that?
Oh, okay. Okay, join.
Okay, okay, sure. Hello?
I hope, sir, I'm audible now.
Now it's audible. Now it's audible.
Yeah, yeah.
Loud
Thank
and
you.
clear.
Yeah, uh, just a second. Yes, sir. Uh,
Yes,
so,
yes, I can hear.
so what? Thank you so much for your presentation, and thanks to you, we can see a different angle with respect to how to actually use AI ethically. So far, whatever we have discussed, we have talked about a lot of frameworks and lot of AI tools. But the assumption was whatever is giving the answers are there, we will just expect kind of accepting them as it is. but you have showcased, demonstrated that it's not that every time whatever is this whatever response comes, it's actually correct. So what I was requesting, if possible, if you can just share a couple of conversations in which and afterwards you can just mention which particular questions AI answered wrong. So later on, the participants can refer to them and learn from them.
Oh, so where do
And
I share that? Right now, where do I share
you
that?
can
Right
share.
now,
You can share with me afterwards. There is one share button on the top right corner of this particular chat, and this is also for participants. That whenever you feel that a particular conversation is kind of interesting and insightful, you can just click on that particular share button, and one link will be generated, and that link you can share with your students. Right, whenever you feel, or if answers are good, then you can share with your colleagues or students also, and you can also share bad examples, just the way Dr. Rahul Muthu is
are you
going to
referring
share
to
right
share
now.
on the WebEx or share on the ChatGPT?
Share on the chat GPT. If you click on that
Ah,
particular
okay, okay,
share
got it.
button,
Sorry,
oh,
sorry.
okay, yeah,
So
sure,
you want
sure,
no, so
yeah,
you
yeah,
want me to
sure.
share that with you? Is that right?
If possible, you can also share in the chat box right now. Otherwise, you can just share it with me afterwards on my via email. I will share with the participants, right? So that
Okay,
they
okay,
can
yeah, because
do the
I can
yeah,
do it
yeah,
in a few minutes
yeah,
here.
yeah.
I can
Ah,
say,
yeah.
rather
So,
than live
so it's
right now.
in general very underrated feature of ChatGPT. So I recommending all the participants also to utilize it. That you can share
So
the entire conversation. And
yeah,
without
I can
any
do that. Oh, I
identity.
see. No, I can see that share right now. I can see that share right now.
Yes,
I
yes,
didn't know
yes,
that.
yes, yes, yes. Right,
I
right,
am
right.
somewhat
So
new to this.
without right, right, sure, sure.
Without,
No, it is in general. I'm also referring to all the participants. They can also do the same. That whenever they feel that something is insightful or some bad examples, also they can share with the students. And that's it. Thank you so much, sir.
yeah,
And
I'm
thank you
just
so much for
putting
your
out.
time. And
No, I'm
yes,
just typing this here. So
right, sure,
if I
sure.
type it, it will happen, right?
You can just click on that particular copy
Yeah,
link,
no, I
and
did that,
then
and I.
the link will be copied, and
So this will be a
yeah,
good one because
sure, sure.
after some two rounds, it gave a good answer. So this is
Right,
a good. So
right. Of
if
course,
it
of
gave
course.
a bad answer, then I revised it. It gave a good answer. But that other one,
Right.
I just share one more. So if the next talk will continue now, right? I guess.
Right. Okay. Okay.
So
So
thank you.
those
I will just
specific
paste it.
comments, I will. Right, right.
Yeah,
If
I
you
will
can
paste
just
it right
write
here.
in one or two lines that which ones are good ones, and particularly we will be interested in knowing the bad ones,
Okay.
because those are the
This
right. It's an
is
imbalanced
good.
data set in some sense, because we get bad examples very
Yeah,
rarely.
this
That
is good
at
upon
least
revision. So this is good upon
good.
revision.
Right,
But original
right,
was
right.
bad.
Of course, of course.
So I will share the other one here. I'll type it here and then.
Right, right, right. Sure, sure, sure. And
Thank you.
also, what I feel that this is also kind of opens one more interesting dimension, that for writing purpose, like when we talk about language like English, right? Most of the times we feel that responses are good, but when we talk about technical aspects like algorithms or mathematics or problem solving, so then
Right.
the responses may not be up to the mark. So
You're right.
it's up to the
Initially, you are
users,
like,
and especially faculty members to verify. And also, I request participants to ask questions if any. And sorry for the interruption and some
no,
issues with internet, but
it will happen. That
overall
would
it
have been
was
any early.
very that the at least from Muthu's side, the internet connection was fine and the talk went good. Thank you, sir. Thank you so much once again.
I don't know. I'm reposting the same one or.
So
Oh, this is the good one. This is the bad one. So I'll post the other one
okay,
also here. So is the conference
right,
still going
sure,
on? Will this window be
sure.
open? Can I post on this
Yeah,
chat?
the chat box is anywhere. Yes, yes,
So
you,
I will
anything
continue. You can
you can
terminate this. I will continue posting on this. I
sure,
will
sure, sure, sure,
stop my video
sure.
and stop, and you can. I will just post whatever I can on these things.
Right, right, sure, sure. So we'll just take a break for I guess 2 3 minutes, and then we will continue with the next session. Thank you so much, sir. Sir, you can stop sharing. Your screen is visible, sir. Thank you.
Yeah, now it's done. Stop sharing. I forgot to stop. Now it's okay. I think.
Yes, yes, sir. It's not visible now. Thank you, sir.